Okay, let's start my talk. Thank you for joining my session. I will be talking about how does Lrama makes the Ruby process grammar goes. Dvrojudu, Birma Sam Solutions to Mog Doju Bosnu. Is the pronunciation correct? Okay, I will speak English from here. I'm so happy to be talking at such an amazing Ruby conference like Euruko 2024. It's an honor to talk at such a great conference. And so this is my first time visiting this country, Bosnia, and Bosnia is such a wonderful place. The food is tasty and it's incredibly comfortable and enjoyable to spend time here. And I love Ruby and beer, so I love Bosnia as well because Bosnia has a great rubies and a great beer. Yeah. And okay, please let me introduce you to the great international Ruby conference in Japan. The conference is called Ruby Kagi. One of the key feature of this conference is where you want find talks about closed source products or soft topics. Instead, it's a place for open source developers to talk about the open source code related to Ruby they developed. Additionally, this is the participation of many Ruby committers and Ruby's from various countries. If you want to feel the energy and passion of many Ruby committers and Ruby's in Japan, let's meet next April in Ehime, Japan. Not only will be surrounded by enthusiastic lobbyists, but you'll also experience incredible local cuisine and some best hot spring. We're looking forward to welcoming you. Okay, so on this talk is possible thanks to general support from Ruby Association in Japan called Nihon Ruby no Kai, who helped cover my travel expenses. I'm incredibly grateful for their support. Okay, so let me introduce myself. I'm Yudai Takada. I'm this YDH, call me Wider, is my handle on social media. You can call me Yudai or Wider. And I come from Osaka, Japan. Osaka is home to a famous Osaka castle and is known for its diverse food culture and vibrant performing art. I hope you will visit. Okay, back to my information. And my hobby is doing open source software programming in my leisure time. And I'm a member of RubyCop Aspect team at RubyCop headquarters. Specifically, I'm the maintainer of RubyCop Aspect, RubyCop Capra, RubyCop Factory Bots, and the RubyCop Aspect Direct. And I'm also a member of committee's maintenance team. And I'm on the maintenance team as a committer for Lrama. And I'm also a contributor to CRB. Okay, I've already published today's slide. You can see the slide if you load this QR code, or I'm also sharing it on X or Mastodon after this talk. Please search the post and find these links. Okay, all right, let's start today's talk. And today's talk is about Lrama. So I have very good news for all the Ruby parsers folks out there. This is the first talk in Europe about Lrama, and I'm excited to share it with you. Okay, so let's begin our journey story about Lrama. Okay, Lrama is a parser generator that generates a parser using the error parser implemented by Ruby. It outputs error parser in C languages with passy as input. Previously, this parser was generated using the GNU Bison parser generator, but since Ruby version 3.3.0, the parser is generated using Lrama. So why did we switch from GNU Bison to Lrama? There are two main reasons. First, we need to support multiple versions of Bison. Because when Ruby users build Ruby from source code, it uses the Bison installed in their environment. So they need to be able to build with different versioning of Bison. As a result, new features added to Bison were not immediately available. And second, it had to add features to extended Bison. Bison is not only used by Ruby, of course, but also by many other users. For example, PHP, Perl, MySQL, Postgres. Changing it requires a lot of tweaking and discussions. So it made sense to move from Bison to Lrama. And the current Lrama maintenance team consists of 3 people. The author Yuichiro Kaneko and 2 committed, Junichi Kobayashi and me. When you when you first saw the name Lrama, you probably thought pronunciation is so difficult, right? It's pronounced like Lrama. Yes, it is the same as the animal llama. It is named after the compatible parser generators yak and bison. It's named for the furry and quadruped animals like yak and bison. So why not llama LLAMA, you might think? However, our llama generates LALR puzzle generator. So it's llama, all right? Okay, so next, let's talking about error puzzle that Lrama generated. Error puzzle means it requires one token in input stream to decide what to do, and left to right scanning of the input, and the revision that replaces the rightmost non-terminal symbols of a sentence form at each step in the revision is called the rightmost revision. This section is summaries. Lrama is a pure Ruby error puzzle generator, and in Ruby versions, version 3.3.0 replace GNU Bison with Lrama. And error puzzle refers to look ahead, left to right, rightmost reversion puzzle. Okay, let's now move on to the components related to parsing in Ruby. The 3 relevant components are the lexer and parser and the compiler. Strictly speaking, lexer and parser are tightly coupled, so parsing is performed for each token split by a lexer. But it's described here as a separate phase for explanation. The text is transformed by each module into tokens, abstract syntax trees, and instruction sequence. Okay, let's start with lexer. In this phase, lexer splits the text into tokens. This means that the Ruby source code you write is now converted into tokens. Let's look at the example. Method definition shown on this slide. This text is DUL space METHOD blah 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 is understandable to us as a meaningful string. But it is really just string of bytes. Yeah. So let's split into set of meaningful characters into tokens. For example, let's split def, method name, def balances, and blah 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 into meaningful set of characters. This is a lot of lexical analysis. Okay, so let's move on to the parsing phase. This phase takes token split by lexer and creates abstract syntax tree. And this phase checks the tokens, and this phase checks the tokens received from lexer and for grammatical conformance and based on abstract syntax tree. And appropriate error handling is done for grammatically incorrect programs. Therefore, it is responsibility of the parser to convert string of token received from lexer into an abstract syntax tree. And you can run Ruby with the dump parse option to see what the parser does. This is a AST, abstract syntax tree. Yeah. Finally, the compile phases compile the abstract syntax tree into bytecode that YARV can execute. And YARV then executes the bytecode and executes the program. And so YARV is, wait. We completely understand what the YARV is. We heard the YARV create a keynote yesterday, right? So skip. Okay. And so you can see how the compiler works by printing the results of the Ruby VM instruction sequence compile method, like this. Okay. Now that we have seen the components associated with parser, what does parser generator do? The parser generator generates a parser from formal grammar specification. It takes a set of rules that define the syntax of a programming language or data format and generates code that can parse strings according to those rules. The parser generator, as shown in the figure, receives the file defining the rules and generates the parser code. And this section summarizes components related to parsing, lexer and parser and the compiler. Parser generator generates a parser source code from a set of rules defining the syntax of programming languages or data formats. Okay, and completed the introduction to the component related to parser in Ruby. So let's move on to the parser grammar. What is a parser grammar? The good way to understand the grammar handled by parsing from the diagram of Chomsky hierarchy, which is the inclusion hierarchy of formal grammar that generates formal languages. In Bison, if you look at the Bison documentation, in order for Bison to parse languages, it must be described by context-free grammar. Yeah, the same is true for Lrama. So if you look at the diagram of Chomsky hierarchy, this is which the error puzzle is possible. So what's the grammar for expressing context-free grammar is Backus narrow form, as well as BNF, is a notation for expressing context-free grammar. BNF is a standard format for describing context-free grammar, and it is used to define the syntax of programming languages and protocol. Okay, so let's take this BNF as an example. This is an example of a BNF that represents the addition of numbers. This can be divided into two main categories, LHS and RHS. Simply put, LHS is the symbol being expanded, and RHS is the result of that expansion. Two types of symbols exist in, and two types of symbols exist in the generation rule section. First, terminal symbols are final pass symbols that are not further expanded, corresponding to concrete word or tokens, like a keyword identifier literals in the program. And non-terminal symbols are symbols that further expanded into other terminal or non-terminal symbols according to grammatical rules. Then represented intermediate structure or syntactic parts of grammar. And here is part of defining actions. This defines the processing and action to perform based on the grammar rules during parsing, while parsing itself constructs a syntax tree according to grammar rules. Actions are executed in process and perform processing related to syntax tree construction, semantics, analytics, and code generation, and so on. The C code in action can refer to the semantic value of components matched by the rules with the construct jar n, which stand for the value of n's components. For example, jar1 in the top line refers to the value of the token named number. jar behaves like a return value. In this example, the sum is stored into jar, so that it becomes the semantic value of addition expression just recognized by the rule. Okay, that concludes our introduction to the basics of BNF. And in Ruby, the generation rules tokens, actions, and error handling is reading in BNF in the file named parser. Parser is like a blueprint that tells Ruby how to understand and execute programs by breaking down code into its fundamental components and rules. Okay, so this section summarizes error parser can parse context-free grammar, and context-free grammar can express using backcast our form. And Ruby use BNF in file called parser to define Ruby grammar and behavior. Okay, I've explained the basics about parser and Lrama. Okay, let's talk about how does Lrama makes the Ruby parser grammar good. I would like to consider what the problem was in first place. There were a number of issues, but one of which was a maintainability issue. It is said that parser is very difficult. For example, it can be metaphorically described as a demon castle, hell, and monstrous. Yeah. So what's the difficulty? One of the reasons for this is that the grammar provided by Bison is so primitive. Okay, so let's look at what it means to have only primitive grammar. Okay, let's go to first topic. The first topic is that difficulty with numbers parameter. As mentioned earlier, the C code in action can refer to the semantic value of the component that matches the rules using the construct that with n, which represents the value of the nth components. This example is very readable, but it's actually more complicated. This is a real case in Pathway. But some action codes are omitted for explanation. When defined in this way, it would be very difficult to know which index is the fifth or seventh. The correct answer is FL algorithm is fifth and lambda body is seventh. Therefore, therefore named reference was introduced by Junk 0612. This is one of the feature of Bison. This feature allows the original symbol name to be used as a named reference. You can also assign areas for reference by enclosing it in square brackets in the role description. For example, let's write this BNF using named reference. Named reference allow you to describe reference as this slide. Okay. In this way, references can be made by the name of symbol on the RHS. And aliases can also be utilized this way to make references in actions are easier to understand. In this way, we were able to make the references of the action also comprehensible. Yeah. Okay. So move to second. Before I explain the issue, I want to think about for a moment. Okay, what would you do if you had duplicate code or logic in the software you were developing? In Ruby, maybe break down system into reusable components like methods, modules, classes to avoid duplication. In Bison, there is no way to do anything. Yeah. If you have heard this far, you will be aware of the fact that there is no means of abstraction in Bison like there is in methods. So, all right, let's look at the real case. This is a BNF representing keyword arguments. And this is the BNF that represents the keyword argument in the block. And so notice that those two have all the same structure and same actions except for some non-terminal symbols. Okay. But we didn't have the syntax to structure these things. So therefore, I introduced the parameterizing rules. What this means is that the definition of a non-terminal symbol can be parameterized with any number of other terminal or non-terminal symbols in the generation rules. In short, naming the pattern clarifies the intent of the rule and allow for pattern reuse. The idea for this parameterizing rule was not conceived from scratch, but was implemented based on the functionality implemented in main here, LA parser generator for OCaml. If we apply the parameterizing rules, these two generating rules with the same structure and same actions. Okay, so this is after. This is abstraction allows us to extract generating rule with common actions and structures. Parameterizing rule have made the parts of generation rules insanely simple. For the first time, it is possible to extract the structure with Ruby's parser grammar. The parameterizing rules is defined in this way, and this is a parameterizing rule indicating options that is a generic structure. Let's look at it from the left side. Option is the name of parameterizing name, parameterizing rule, and X indicates large X indicates the argument, and the large X on the right side is expanded to argument passed by using the rule as parameters. Refers to the symbol expanded to large X. Okay, so let's look at an example of this generation rules adapting the parameterizing rule to it. Rewriting using the parameterizing rule for the generation rule would look like this. And in this case, the backslash n passed on the side using the parameterizing rule is expanded. And so backslash n is also expanded on right side. The parameters passed on the side using the parameterizing rule are expanded. We now have the way for structuring, but wouldn't we also want to use very generic structures parameterizing rule, for example, without having to define them? So Lrama provides those general parameterizing rule in form. of the standard library. Lrama provides a standard library of rules with a general structure, such as option or list, and so on. Standard library is stored in a file lib slash Lrama slash grammar slash standard lib.y, which is embedded inside grammar file when before parsing. And we also provide variances for the three rules option list and no-empty list, which can be leading like regular expressions. This allows for simpler expressions. So the standard library and LSs allow this generation rules to be expressed in this simple way. So we have gained what in Ruby terms could be compared to having method definitions and the standard library at our disposal. Okay, so I've explained some approaches to improving the grammar. I think so. Ruby parsers grammar is now go right. Okay, so this section summaries currently where the replacement of the parser generator from Bison to Lrama, we have more powerful and richer grammars. And named references solve the problem of easily hard to read references. And parameterizing rules gave us great power to abstract structures. And the syntax continues to evolve, and the greatest of all time continue to be updated on daily basis. Other syntaxes not covered in today's talk includes the design and implementation of inlining and the conditional expressions. This will get more power to Ruby parsers grammar, I think. Okay, finally conclusion. Conclusions are one of the problem with parsers was the issue of mentionability. It was suggested that just extending the grammar would bring significant improvement to the Ruby parser grammar. The syntax continues to evolve, sorts out the development of Lrama, and the G.O.A.T continue to be updated daily. And so it's not just maintainability issues that Lrama want to solve. This is a lot to map, and we have a lot of goals. So we will continue to improve Lrama and pathway to take full advantage of the great power of Euruko. Okay, if you are interested in the Lrama project, please consider giving it a star on GitHub. And also, we are always looking for your feedback, and we also want to be a part of this project if you're interested. Okay, so let's rebuild the future of the process together. Okay, thank you.